Hi guys, welcome back to my channel Pirai Academy. In today's video, we are going to see about an important question called merge intervals. So it is lead code question number 56 and it is asked in Soliton Technologies for long programming round for 2026 batch. Okay, and also it is asked in Turing for SDE role. Fine. So see here, given an array of intervals where intervals of I will be consisting of start of I and end of I. Merge all overlapping intervals and return an array of non-overlapping intervals that covers all the intervals in the input. Fine. So just for example, let us take. So this is our first example. Okay. In this first example, they have given some sort of intervals, and in this intervals, can you say what are all those that are just overlapping? You can easily say that these two intervals are the only one that are overlapping. But how you are telling this? Because see here, this 3 is greater than this 2, right? Or else inside this 1 and 3, this 2 is present. Anything, okay? Then it is called as a overlapping. Fine. So how we are going to merge these two things? We are going to merge these two things as 1, 6. Simple. And anyhow, other intervals are not overlapping. So just leave as it is. Fine. Again, let us see another example. So in this example, they have given 1, 2, 2, 3, 3, 4 and 4, 5. So here, this 1, 2 and this 2, 3 are overlapping. Can you understand this? Are overlapping. So we will be consisting this as 1 and 3. Okay. Again, this 1 and 3 and this 3 and 4 are overlapping. So we will be consisting as 1, 4. Again, 1, 4 and 4, 5 are overlapping. So we will be merging it and our output will be 1, 5. Simple. Can you understand this? Okay. So this is going to be our examples and how we can represent this easily. So for example, just take this as our example. Then for whenever the question is about the intervals, then you want to visualize those things. Okay, instead of just seeing that randomly, you want to visualize them. How you are going to visualize them is whenever there is a intervals, then put a number line. Okay, put a number line. Okay, fine. Now here comes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. Okay, here there are totally 18 numbers. Okay, fine. So initially, what is our lowest number that is present in our array or lowest starting point? So it is 1, 3. So just map it. So 1, 3 will be where starting from here up to here, right? Again, next thing is 2, 6. So 2, 6 will be from here up to here. Next thing is 8, 10. So from here up to here, and then 15, 18. So it will be from here up to here. Hope you understand this. Now from this diagram, you can clearly see that these 2 points are overlapping. Other than that, there is no overlapping. Okay, so you want to just merge them as 1, 6. That's it. Can you understand this? Yes. Okay. Now we are going to the exact logic. So this is going to be your approach, or this is going to be your intuition. Okay. In specific way, it is going to be your intuition. From this, you can write your own logic. You can try that logic by yourself. If you don't know, just watch this video next. Okay. Fine. So let us take the same example above. So this is going to be your example, right? Now. Initially, what are all the things I have done here? I just taken the lowest value to the highest value, right? Why I am taking like that? Because you can see if this 1, 3 is there, okay, what is the immediate next of this 1, 3 that is going on to be in the number line? It is going to be 2, 6. Next it will be 8, 10. Next it will be 15, 18. So from here you can say we want to sort them in a ascending order with respect to starting point. So sort them ascending order with respect to start point. Okay, this is going to be your first step. So after sorting it, it will be 1 comma 3, 2 comma 6, 8 comma 10, and 15 comma 18. So these are all going to be your intervals after sorting them. Fine. Now what is the next step I want to do? I want to check whether the current pointer is the current point and the next point is overlapping. So to do that efficiently, I'm going to take a resultant, because we want to return all the non-overlapping intervals, right? So I'm going to take the resultant array or resultant matrix in specific. Okay, fine. So initially I am at this point. Whether my result contains any intervals? No, just put them as it is. Fine. Now I am going to the next part. But see here, the starting point of the next interval and the ending point of the current result last interval. Okay, this is greater than or equal to this, right? So from here I can tell you that we are going to update. How we are going to update? We are going to update this 6 here. Okay, fine. I will be telling you one mistake I have done here. I will be telling you at the end. Okay, fine. Now we are going to take the next thing. So next thing is what? 8. So whether 6 is greater than or equal to 8? No, it is not. So just insert that interval as it is. Fine. Now we want to check whether this 10 is greater than or equal to 15. No. So we don't want to do anything. Just insert 15 comma 18. That's it. Simple, right? So this is going to be your resultant. Hope you understand this. But for example, in some other cases it will be, let me take any other color. In some other cases it will be 1 comma 3 or 1 comma 6, okay, or 1 comma 5. Now here comes 2 comma 3, then here comes 8 comma 10. That's it. Okay, just assume this is the given merge interval example, okay, or test case. Then here, by using your resultant, how you are going to do? So first of all, the resultant is empty, so you want to take the first thing. So this you will be taking this. Okay, now you are going here. So this 5 is greater than or equal to this 2. Perfect. Yes. So what we are going to do? We are just going to replace this 5 using what? 3. But whether it is correct? No. So what we are going to do is we will be leaving as it is. Why? Because this end is less than this end. Okay. So we want to update here as what is the maximum of both the ends. That's it. Can you understand this? So this was the mistake I have done here. I just directly updated the 6. No, we want to take the maximum among the 6 and 3, and among this the maximum is 6. That's why we are updating the 6 here. Hope you understand this. So let me rewrite the algorithm. First of all, sort them in ascending order with respect to starting point of each and every intervals. Okay, and then what is going to be your second thing to do in the approach? Okay, so the second thing you want to do is you are just going to traverse one by one. Okay, and if the resultant is empty, then just insert the interval. Okay, just insert interval. Fine. Otherwise, what should you do? You should be checking the last interval in the result. The last interval in the result ending point is greater than or equal to current ending point. If it is so, then what should you do? You should be updating the max of end points of those two in the last interval's ending point. Okay, or else if this condition is not satisfied, then what you will do? You will be just inserting the interval. Insert interval. That's it. So this is going to be your entire logic. And now tell me, what is the time complexity for the solution? So the time complexity will be O of n log n for sorting it in a merge sort algorithm, and plus we are just going to traverse one by one, right? So it will be n. So overall time complexity will be O of log n, and space complexity will be O of n, because we are just taking a merge sort algorithm. In merge sort algorithm, we will be using a auxiliary space. Okay, and this resultant will be not the auxiliary space. Why? Because this resultant is just you want to return. Okay, so it is not going to be your auxiliary space, it is a resultant. So it is not going to be your space complexity. So this is the time and space complexity analysis. Now let us see the code so that it will be more clear. So I'll be showing you the Python code for Turing. In Turing, you are going to do the coding part in Python. Okay, but in Soliton, it will be C program. I'll be giving the C program in the description. Just go and watch it. Okay. If you are going for the Turing interviews, just watch this video. Okay, fine. So first of all, I want to sort them in a ascending order with respect to starting point, right? So it is like just to do a sort operation in intervals. That's it. Okay. Now result will be of empty list. Now I am going to traverse along the intervals. Okay, and I am going to check whether there is the resultant, there is any element in the resultant, and also the resultant's last index endpoint is greater than or equal to the current interval's start point. Then what should I do? I should be just updating the end as maximum among both the ends. Okay, else what should I do? I just append the interval. That's it. So this is going to be your entire code. Okay, let me submit it. Yes, it is submitted successfully, and I think I just wrongly wrote here as a end point. Here it is a start point, the current start point. If the resultant's last index end point is greater than or equal to the start point of the current index or current interval, then we want to just do what? We are just going to update the maximum of the end of the current or the already existing in the resultant endpoint. Okay, fine. So this is going to be your overall code. To know about these kinds of algorithm, just go and search in my YouTube channel. If you really like this video and subscribe to my channel. Don't skip any videos in this playlist, because all videos will be useful once you are appearing for the interviews. And there are plenty of videos in my playlist, and just go along them and just study. Like I just uploaded the separate playlist for greedy, recursion, trees, and etc. so on for the problem solving, and just go and watch it so that you can build a strong foundation on problem solving. And if you don't know about problem solving, then just go and watch my basic playlist. I will be giving that playlist in my description. Thank you.